This river has been flowing for 10,000 years, but for 10 of those years, the critical 10, nobody was measuring it. So how do you design a 75-meter dam across a river you only half understand? The answer begins in 1963. The Jubba River hydrological assessment spans 63 years, from 1963 to 2026, built around two primary monitoring stations, Luke in the north, where the river descends from the Ethiopian highlands, and Bardhir, 400 kilometers south, where it passes through Somalia's heartland. Together, they watch a catchment of 216,730 square kilometers. Over the full record, the Jubba delivers a long-term mean of 5.9 billion cubic meters every year. 5.9 billion. That is the number the Bardera Dam was built to harness. In 1991, Somalia's monitoring networks collapsed. Civil conflict, abandoned field stations, no gauge readings. For an entire decade, from 1991 to 2001, the Jubba River flowed unobserved. For a hydrologist, this is not a minor inconvenience. This is a structural crisis. The 100-year design flood, the extreme event that determines whether a dam holds or fails, requires decades of continuous data to calculate accurately. 10 missing years, right in the middle of the record. So J-Rats asked, what if the river left a fingerprint somewhere else? Satellites don't care about civil war. While ground stations went dark, two global observation systems kept watching. TRMM, the Tropical Rainfall Measuring Mission, recorded rainfall patterns across the entire Jubba Basin from orbit. ERA-5, the European Centre's Global Atmospheric Reanalysis, reconstructed atmospheric conditions at 6-hourly resolution going back decades. J-Rats engineers built a satellite-to-proxy transfer matrix, a mathematical bridge between satellite-measured rainfall and the historical river discharge at Luke and Bardhir. By calibrating that relationship against the known years, before 1991 and after 2001, they could run it backward. Into the gap, the reconstructed decade shows a mean estimated flow of 144.5 cubic meters per second. Within 5% of the pre-gap average, not measured, reconstructed, but reconstructed against 60 years of verified field data. With the full record restored, J-Rats applied Phase 2, stochastic extreme value modeling using log Pearson type 3 probability distributions. The international standard for flood frequency analysis, the historical median, the river on an ordinary day, is 152 cubic meters per second. The critical drought floor, the driest 10% of years, drops to 12 cubic meters per second. And the 100-year design flood, the extreme event every major dam must survive, reaches 2,031 cubic meters per second, 13 times the median, in the same river. The Bardhir Bridge constrains the operational safety limit to 1,800 cubic meters per second. Beyond that, the max structural containment test boundary. That range, from 12 to 2,031, is what the Bardera Dam was engineered to contain. Phase 3 translated the stochastic model into physical geometry. Using the Francis head discharge equation, J-Rats sized the weir overflow structures, optimized to contain flow, prevent backwater pooling, and route extreme events safely over the crest. And a strict 10% eco-reserve flow guarantee was written into the operating rules. When the river drops to its drought floor, 15.2 cubic meters per second must always pass downstream. The delta plain will never run dry. Every dimension of the Bardera Dam traces back to this dataset. The bankful discharge capacity, 583.6 cubic meters per second, is the inflow rate the reservoir was sized to absorb. At that rate, it takes 127 days of sustained bankful flow to fill the 6.4 billion cubic meter reservoir from empty. The The 100-year flood figure drives the flood pool elevation at 75 meters, the maximum containment boundary, and the eco-reserve protocol is embedded in the dam's operating logic. Non-negotiable. 63 years of data, 10 reconstructed from the sky, 1 river, 1 reservoir, 6.422 billion cubic meters, waiting for Somalia. The Bardera Dam. The data behind the structure, the science behind the water.